They'll come and collide. Then find the time when the string becomes taut for the first time after the mass m collides with the ground. Take all collisions to be elastic. So both will descend. They'll come here, no? They'll collide. I'm trying to show the sequence. So both are released from rest. Both are released from rest. So they are height, and let this be L. When they approach here, both will have velocity u1 and u2. They're going to have a speed. Let's see, no. Elastic collision occurs. So what should happen to the speed of the block m2? It will get reversed, and it will be like this. So what will happen to string very next moment? The string will become loose, no? It was a taut. Now the string will become loose. So this will be u2. Very next moment, the string will become loose. This will be loose, taut. Next, so what is the sequence? They both collide somewhere here. The both will collide. You can draw some bigger diagrams. Huh? If you are interested, you can draw it. And strings are, where is the string? String will be somewhere here. Keep it like this here. Again, what is the type of collision? Elastic collision. They'll exchange their velocities. They'll exchange their velocities, and they'll start moving up here. It's asking, find the time when the string becomes taut for the first time after the mass m collides with the ground. From here is what is asking the question. How to do this problem after this? I think our question should begin from here, no? Am I right? Find the time when the string becomes taut for the first time after the mass m collides with the ground. First and second, third diagram is what we just brought it. We have to discuss the question from here. It's an elastic collision, so let's go for quotient of restitution. Relative velocity of separation should be equal to relative velocity of approach, and as it is equal to 1, so therefore the magnitude of that should be equal, no? So what is the relative velocity of approach? So what is the u1 and u2? Both will be equal, no? Equal to 2gh. So this I'll call relative velocity of, and relative velocity of approach, and this is the relative velocity of separation. So let me write v relative, u relative. As equal to 1, the magnitudes must be equal. So what is the u relative? U relative should be u1 minus of u2. So there should be 2 root 2gh, and the magnitude of that so when the string is just taut, so this is what happens here. Again, when the string becomes taut, what do we expect here? No. you should not mess up things here. The relative velocity of separation must be equal. So this will have velocity u2, this will have velocity u1. The relative velocity of separation must be equal to how much? Should be equal to 2 root 2 gh. And what is L? L is our distance. So from here to here, the time is what? Being asked here. No? So what time it will take to collide this? These two times, will it be equal? TA and TB. They collide, again they'll get separated, again the string will become taut. Go back to relative velocity. What is the length of the string? This is L, no? Length of this separation is L. Problem very simple. If it idea flashes for you, it's very easy. So what is TA? I should write it. TA should be equal to L by 2GH, no? And what should be TB? TB is also L by 2 root of 2GH. So what is the total time? TA plus TB, which is equal to L by 2 root of 2GH. I just took help of this concept. As E is equal to 1, I'm equating both. Maximum, the problems will be there where you need not to bother about the mathematics. Sir. Since the elastic collision, we are able to do problem very easily. In elastic, I think little bit difficult. We have to do a lot of calculation. Will come, lot of mathematics will be involved here.